Hello guys, welcome again to my video. Today we are going to program a convolutional neural network. Okay, first we are going to import some libraries that we are going to need. The first one, you know it, is the NumPy to load a file with the database, and Keras models sequential from Keras layers. Okay, with these libraries we are going to make our neural network, but first of all, this neural network will work for prediction for diabetes, and well, our database is allocated in our file, this file diabetes, and this has all the data: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, and the outcome is the prediction, or not the prediction, is the real data we got from this information. With this data we are telling the database that this person has diabetes, and with this data we are telling that this person doesn't have diabetes. Okay. We are going to import it, database fpd.read csv, and we are going to print it to check if we are getting the real data or if our program is already getting the data. Okay, I have an error here. Not module name panda. It is because it is named pandas. Okay, and now we have a lot of errors here. It is because of the name of the file. It is diabetes 2. Okay, with this we are getting our data. We are going to clear this, and I am going to comment this line. Now the features, they are all the outcomes. Axis equals to 1. Now we are going to print the features. To check if this is working. Okay, this is working. What we did here, we delete the outcome because we only want to read this information. But okay, but we have another variable, and this variable will save all the outcome. and let's print it to check if this is working as should be. Okay, with this we got our predictions, or not the predictions, the outcome, and this is working well. Okay, we are going to need these variables to program our neural network. But first of all, we need to create and validate the training data. First of all, we need this variable xtrain, xtest, ytrain, and ytest. This will be equal to train, test, split, features, target, and test size will be equal to 0.1. Let's check if this is working well. Yeah, okay, we don't have any problem here. And now we are going to create the definition of the model. Okay, I have a typo here, definition of model. Our model will be equal to sequential, and this is our instance, and model we are going to add dense 8, input dim 8, activation equals to ReLU. Okay, this is ¿cómo se dice? This is our first layer of the network. It means the data we have in our database. For example, if we open the file again, we can check or we can see we have 8 columns of information. 1, 2, 3, 4, 5, 6, 7, and 8. We are not going to use the outcome, only the data we need for the predictions. We are going to add a second layer. Activation. And we are adding it with 16 nodes. We can add another layer, but only with 8. And the last one will be our response or prediction response of our neural network. And here we are going to use a sigmoid because the last layer with sigmoid or softmax, we are getting better results in the last layer. Okay, the number of neurons are power of 2, and the hyperparameters are these, the one we can modify. Okay, let's print here a message. we a neural network has been created with 5 layers. 3 are hidden. These are our hidden layers, where we have 8, 16, and 8 neurons. Okay, now I'm going to close this. Now we are going to compilate the model with ADAM. That is, it is an algorithm. Model.compile loss equals to binary cross-entropy, binary cross-entropy, and our optimizer that will be ADAM, and our matrix are equals to the accuracy. Let's check first if this is working. Let's test it. Okay, I have an error here in compile because the arguments are wrong. Okay, it is because of this typo. Matrix, no matrix. I'm sorry for that. Okay, our message has been printed. A neural network has been created with 5 layers. 3 are hidden. Okay, now we are going to train our algorithm. Training history equals to model.fit x train y train, comma, we are going to use 100 epochs. Now our batch size equals to 10. Validation data is equals to x test and y test, but this is an uppercase X. And our verbose, it's equals to 1. Okay, just like that. This line takes 10 rows of our database. It train it and modified it, and then take another 10, and then take another 10, another 10, and another 10. The verbose prints all the data. Okay, here we are going to have a loss and inaccuracy. The loss must be going down, and the accuracy must be going up. But if our accuracy is not going up or increasing its value, then we need to modify the epochs. This one, we can have 100, 200, 50. It is necessary to modify it to the value it is fitting to your database. But well, for this example, we are going to use 100. Now we are going to train our curves. But first, let's test if the code doesn't have an error. Okay, with this you can check our accuracy and the loss. If you can notice, the accuracy goes from 68 to 74 more or less, but if the accuracy is a higher has a higher value, then it's better for our predictions. But okay, we don't have an error here in this part of the code. So the next step is to import the matplotlib from pyplot. Oh, what happened? Pyplot. Okay, as PLT. With this, we are going to to plot our results. Ag is equals to history what we want, accuracy. Okay. Well, accuracy is equals to history val accuracy. Okay, the next one is the loss. History loss. And well, loss it's equals to history val loss. Okay, this is with 2s. Okay, now our epochs will have a range from our accuracy. Yeah, like that. I don't know if it is with Magus. Okay. Let's test our code to see if we don't have an error. If you can notice, our accuracy is getting lower values than the last test. This is always changing because as you notice, and as I said, it takes 10 random fields of data or lines of data and test them. Okay, plt dot plot epochs. Back here we need an R, and label it's equals to training ag. Oh my god, I'm sorry. Just like that. Plt.plot epochs val ag color blue label validation accuracy. Plt title training and validation accuracy, and plt.legend plt.figure, just like that. Okay, what else? Plt plot epochs loss R to for the color red label equals to training loss. Plt.plot epochs val loss color blue, and our label is the validation loss. Plt title training and validation loss. Here we are plotting our two values, the loss and the validation. PLT legend and plt.show. Okay, let's test this code to see if we have an error or not. It seems not. The accuracy is always lowing down for its values. And our plots. Oh, okay. Legend. Yeah, I have an error here. This is legend, no legend. Okay, let's try it again. It seems we are getting better values for our accuracy. Oh my god, another mistake. Label here. Okay, it doesn't matter. Let's test it again, but first I am going to clear the console. Lower accuracy value, but it's okay. We are getting some 18%. And here our accuracy is almost in the same point, but we are having some difference, and our validation loss has a value that almost an equal value. Okay. The next step, we are going to evaluate the model with the training set. Okay, here, evaluate the model with the training set. For this, we need to do this. Accuracy is equals to model evaluate X train with Y train. Let's print our accuracy percent because we want a float value. We want to print a float value. Now percent accuracy multiplied by 100. Okay, and we are going to evaluate the model with the test data. Okay, it's almost the same. Accuracy equals to model evaluate X test with Y test. Now we are going to print our accuracy. Well, I think we can use this. Yeah. So I don't print anything. But let's test this. Our training data, our accuracy is getting lower every time we run the code. I don't know why. But as I said, if you want to improve your accuracy, you need to increase your epochs value. Look at this. This is not um, a good plot, but it's okay. Okay, I have an error here. Accuracy. Yeah, this is our first value, this one, and in the second I have a typo here, but this was only the only mistake. For the next step, we are going to make the prediction with the set validation. Okay, prediction with the set validation. Predictions equals to model.predict x test and round. We're going to round the predictions. Round x0 for x in predictions. Okay, let's test this to check if we don't have a mistake or an error in the code. Okay, the plot are, oh my god, it's okay. And our prints are not here. Oh no, yeah, they are here. Okay. Okay, this is working now. We're going to create a confusion matrix using scalar dot metrics import classification report from scalar. Oh my god, I always write matrix like a matrix. Matrix import confusion matrix. The matrix will be equal to confusion matrix taking y test and round. Matrix, okay, yeah, matrix style background gradient, just like that. Okay, let's test our code to check if we don't have an error again. The accuracy is getting so low. Okay, let's check the plots. Okay. Oh my god. What is that? Okay. Okay. Scalar matrix. No, I'm sorry. From scalar matrix, I need to import confusion matrix. Okay, let's test it again. Okay, the plots are here. This is a weird shown of data, but okay. Okay, we don't have a problem here. So let's make our prediction. X new must have the 8 columns of value. Let's try with this. 72, 35, 0, 6, 12. Just like that. If I remember, pregnancy, no. Glucose, 200. Blood pressure. The last one, outcome, age, and diabetes pedigree function. Okay, the last one is age. Let's try with a person with 23 years old. Okay, x new is equals to np dot expand teams x new 0. This expands the dimensions of the vector. np shape x new. Expand teams. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Prediction is equals to model.predict our new data, and let's put it like that. As type int. We're casting this class equals to no and yes. I have an error here. Okay, class diabetes, and we are going to print if the person has diabetes or not. Yes. Class with our prediction 0, 0. Oh, typo here. Okay, let's execute it. And okay, this is our plots. Oh my god, Fred. Okay, another mistake. Where sequential has not attribute predict. ¿Dónde eres? 93. Okay, let's try it again, just to check if a person with these values has diabetes or not. Okay. Oh my god, okay, another error here. Oh, it is because I wrote well, this is wrong. Okay, and let's clear and try it again. our accuracy is so low, so okay, it says that a person has diabetes. Well, guys, with this you have your neural network, your CNN, and remember, if you get low accuracy, you can increase the value of the epochs, this one, and maybe you will get a best accuracy to make your predictions. Guys, I really hope you like the video. Please don't forget to like, to comment, and to share, and to subscribe. Bye.